In this video on standard form, we learn about adding and subtracting numbers written in standard form. Now, for this first video on this topic, we'll be carefully looking at cases when both numbers are written in terms of the same powers of 10. Now, there are 8 examples to get through, each of which is different, and the first one we can see here. We need to add 3.7 times 10 to the power of 5 plus 2.1 times 10 to the power of 5. And to do that, the first thing we notice is that both numbers involve the same power of 10, that's 10 to the power of 5, and consequently, we can place that 10 to the power of 5 as a factor to this expression and state that it's equal to, in parentheses, 3.7 plus 2.1. So I'll go ahead and write that. That's 3.7 plus 2.1, close parentheses, times 10 to the power of 5. Now, 3.7 plus 2.1 is equal to 5.8, so we can state that this equals to 5.8 in parentheses times 10 raised to the power of 5. Finally, now that there's no longer an addition inside this pair of parentheses, we can get rid of it to state our final answer as 5.8 times 10 raised to the power of 5. And that's the first example done. Notice that in this case, the sum of 3.7 and 2.1 was less than 10. And that's important because, as I've written in the upper right-hand corner here, when writing a number in standard form, the number multiplying the power of 10 has to be greater than or equal to 1, but must be less than 10. So in this second example, example B, let's see what happens when the sum of the two numbers is greater than or equal to 10. Here it is. Say we have to add 8.3 times 10 to the power of 6, and 3.5 times 10 to the power of 6. Well, firstly, we notice that once again we're dealing with the same power of 10 in each case. Indeed, we have 10 to the power of 6 here and 10 to the power of 6 here. And so just as we did for the first example, we can write this expression in factored form. In other words, we can go ahead and state that this equals to, in parentheses, 8.3 plus 3.5. So I'll just write that. That's 8.3 plus 3.5, close parentheses, times the power of 10, which is 10 to the power of 6. I now add the two terms we have inside this pair of parentheses, and you can go ahead and check, but 8.3 plus 3.5 is equal to 11.8. So I'll just go ahead and write 11.8 inside that pair of parentheses. And that's still multiplied by 10 raised to the power of 6. Once more, I can now get rid of this pair of parentheses and state that this equals to 11.8 times 10 to the power of 6. And at this stage, although one may be tempted to stop, we need to carry on. Indeed, because 11.8 is greater than 10, we need to take a factor of 10 out of it. Here's what I mean. I'll go ahead and rewrite 11.8 as 1.18 times 10. And just to be clear, 1.18 times 10 is equal to 11.8. And that's still multiplying 10 to the power of 6. That was our power of 10. Now, when multiplying this 10 to the power of 6 by 10, it turns into 10 to the power of 7. And so, replacing 10 times 10 to the power of 6 by 10 to the power of 7, we obtain our answer written in standard form. That's 1.18 times 10 raised to the power of 7. And that's the answer. I carry on. Let's look at some subtraction now. And so I'll say question C right here. And say we need to calculate 5.9 times 10 raised to the power of 7 minus 3.4 times 10 to the power of 7. Well, once again, the first thing we notice is that both numbers involve the same power of 10. Indeed, we have 10 to the power of 7 here and 10 to the power of 7 here. And consequently, to calculate this subtraction, we can write it in factored form and state that it's equal to, in parentheses, 5.9 minus 3.4. So that's 5.9 minus 3.4, close parentheses, times 10 to the power of 7. Now, 5.9 minus 3.4 is equal to 2.5. So this equals to, in parentheses, 2.5 times 10 raised to the power of 7. Finally, getting rid of this pair of parentheses which serves no purpose now, we can state that it's equal to 2.5 times 10 raised to the power of 7. And that's the answer. Now, notice here that when we subtracted 3.4 from 5.9, the result we got, which was 2.5, was greater than 1. And that's important because remember, when writing a number in standard form, the number which multiplies the power of 10 has to be greater than or equal to 1. And so let's move on to the next example, example D, to see how to deal with cases where the subtraction leads to a number which is greater than 0 but less than 1. Here it is. Say we have to calculate 2.3 times 10 raised to the power of 6 minus 1.9 times 10 to the power of 6. Well, again, we can see that in both of these numbers, we're dealing with the same power of 10. Consequently, we can write it in factored form to calculate it and state that it's equal to, in parentheses, 2.3 minus 1.9. And so I'll just quickly write that. That's 2.3 minus 1.9, close parentheses, times 10 raised to the power of 6. Now, 2.3 minus 1.9 is equal to 0.4. So this turns into, in parentheses, 0.4 times 10 raised to the power of 6. Okay, getting rid of this pair of parentheses, which is of no more use to us, this equals to 0.4 times 10 raised to the power of 6. But we mustn't stop there. Indeed, as I said a minute ago, the number multiplying the power of 10 has to be greater than or equal to 1. And so to make sure that's the case here, we're going to borrow a 10 from this 10 to the power of 6. In other words, we go ahead and write that this equals to 0.4 times 10 times 10 raised to the power of 5. And that works since 10 times 10 to the power of 5, well, that's equal to 10 to the power of 6. So we're not changing the value of anything here, we're simply changing how it's presented. Now that we've done that, we can multiply this 0.4 by the 10 that we have here, which leads to 4 times 10 raised to the power of 5. And that's the answer. Okay, that's 4 examples done. Notice that in each of these 4 examples, the powers of 10 that we were dealing with were always positive. So for the second half of this video, let's see how things work when the power of 10 is a negative power. And so we move on to example E, in which we need to calculate 3.2 times 10 raised to the power of negative 5 plus 1.3 times 10 to the power of negative 5. Okay, well, looking at this once more, we can see that both of the numbers we have here involve the same power of 10. Consequently, we can calculate this in the same way as we've done for the first 4 examples. Indeed, we can go ahead and state that that equals to, in parentheses, 3.2 plus 1.3, and so I'll quickly write that. That's 3.2 plus 1.3. I close the parentheses, and that's multiplied by 10 to the power of negative 5. I now calculate 3.2 plus 1.3, which is equal to 4.5, and so I can write that's equal to, in parentheses, 4.5 times 10 to the power of negative 5. Finally, getting rid of that pair of parentheses, we can state that that's equal to 4.5 times 10 to the power of negative 5. And that's the answer. Okay, now in this example, the result of adding 3.2 to 1.3 was less than 10. Indeed, we had 4.5. And consequently, our answer was immediately written in standard form. But so let's see what happens when the 2 numbers we add lead to a number which is greater than 10, which is similar to what we saw in example B, but this time the power on the 10 is negative. So let's see, that would be example F. And let's say we have to calculate 7.2 times 10 raised to the power of negative 7, and 5.6 times 10 raised to the power of negative 7. Okay, well, as in all the examples of this video, we start by noticing that both of these numbers involve the same power of 10. Indeed, we have 10 to the power of negative 7 here, and 10 to the power of negative 7 here. Consequently, to calculate this, we can write this expression in factored form, and we can state that it's equal to 7.2 plus 5.6. And that's in parentheses, so I write 7.2 plus 5.6, close parentheses, times 10 raised to the power of negative 7. Next, I calculate this sum, and 7.2 plus 5.6, well, that's equal to 12.8. So I'll go ahead and write that's equal to, in parentheses, 12.8 times 10 raised to the power of negative 7. I now get rid of this pair of parentheses, so that's equal to 12.8 times 10 raised to the power of negative 7. And now the issue we're faced with here is the fact that 12.8 is greater than or equal to 10. Remember, the number multiplying the power of 10 has to be less than 10. And so the trick here is to take a factor of 10 out of this 12.8, just as we did in example B here. And so to do that, I'll state that 12.8 is equal to 1.28 times 10, and I still need to multiply that by the power of 10, which was 10 to the power of negative 7. And now we need to take care of this multiplication, 10 times 10 to the power of negative 7. Well, remember, when we write 10 this way, although we don't write a power, there is one. In fact, when we write 10, that means 10 to the power of 1. Furthermore, when we multiply two powers of a same number, the result is obtained by adding the powers together. In other words, 10 to the power of 1 times 10 to the power of negative 7 will equal to 10 to the power of 1 plus negative 7. And 1 plus negative 7, well, that's negative 6. And so this equals to 1.28 times 10 raised to the power of negative 6. And that's the answer. We're nearly there. Let's just look at two more examples involving subtraction with numbers written in standard form with negative powers of 10. And so let's see. For that, we'll start with example G, for which we need to calculate 5.6 times 10 to the power of negative 5 minus 1.4 times 10 raised to the power of negative 5. And in fact, before I carry on, what I'll do is I'll draw some separation lines just to separate all the working, like so, and I'll do that over here as well. There we go. And as I'm sure you can imagine, I'm doing that because I can see that I'm going to run out of space here. So rather than writing my working to the right of this expression, I'll go ahead and write it underneath it. Firstly, when looking at this subtraction, we quickly see that both terms involve the same power of 10. Consequently, we can use the same method as previously to state that that's equal to, in parentheses, 5.6 minus 1.4. And so I'll go ahead and write that. That's 5.6 minus 1.4. I close the parentheses, and that multiplies 10 raised to the power of negative 5. Now, 5.6 minus 1.4, well, that's 4.2. And so we can state that that's equal to, in parentheses, 4.2, close parentheses, times 10 raised to the power of negative 5. Finally, since we've gotten rid of the subtraction inside this pair of parentheses, they no longer serve any purpose, and we can get rid of them. So we can state our final answer as 4.2 times 10 raised to the power of negative 5. Done. Now notice here that when we subtracted 1.4 from 5.6, the result we got, 4.2, was greater than or equal to 1. And of course it was less than 10. In other words, the number we got was written in standard form. But now for our final example, let's see what happens when the subtraction we have here leads to a number between 0 and 1, and how to deal with it when the power of 10 is a negative power. And so that's our final example, example H. Let's say we have to calculate 5.6 times 10 raised to the power of negative 8 minus 4.7 times 10 raised to the power of negative 8. Well, firstly, we quickly see that both terms involve the same power of 10. Indeed, we have a 10 to the power of negative 8 there, and a 10 to the power of negative 8 here. Consequently, we can use the same method again and state that's equal to, in parentheses, 5.6 minus 4.7. I'll quickly write that. That's 5.6 minus 4.7. Close parentheses, times the power of 10, which is 10 to the power of negative 8. Now, 5.6 minus 4.7, well, that's 0.9. And so this turns into, in parentheses, 0.9, close parentheses, times 10 raised to the power of negative 8. As in the previous examples, I can now get rid of this pair of parentheses to state that this equals to 0.9 times 10 raised to the power of negative 8. And now we're faced with an issue. Indeed, 0.9 is less than 1. But in standard form, remember, the number multiplying the power of 10 has to be greater than or equal to 1. And of course, it has to be less than 10. But here, 0.9 is less than 1. Furthermore, this power of 10 here is a negative power of 10, which makes it a little less easy to take a factor of 10 out of it. But luckily, there's a nice little trick. First of all, I'm sure you'll agree. This is equal to 0.9 times 1 times 10 raised to the power of negative 8. So far, so good. But 1 is equal to 10 times 10 raised to the power of negative 1. Indeed, 10 times 10 to the power of negative 1 will equal to 10 to the power of 0, which is just equal to 1. And so, using this result, we can go ahead and state that this equals to 0.9 times 10 times 10 to the power of negative 1 times 10 to the power of negative 8. And thanks to this, we can now state that this equals to 0.9 times 10, which is just equal to 9, times 10 to the power of negative 1 times 10 to the power of negative 8. And 10 to the power of negative 1 times 10 to the power of negative 8 is equal to 10 to the power of negative 1 plus negative 8. In other words, that's equal to 10 to the power of negative 9. And that's the answer. And just to be clear where I'm getting this power of negative 9 from, remember that when we multiply two powers of a same number, we add the powers together. So this 10 to the power of negative 1 times 10 to the power of negative 8 is equal to 10 to the power of negative 1 plus negative 8. And since negative 1 plus negative 8 is equal to negative 9, we obtain the answer we see here. And there we go. Now that we've seen these 8 examples, we're all set for adding and subtracting numbers written in standard form when the powers of 10 are the same. And that's it for this tutorial.